All right, we're going to do some more derivatives again today. Today we are looking at product and quotient rule for the derivatives. What does that mean? It means we want to take the derivative of a function where there's a couple of things being multiplied or divided. Okay, notice the product rule up here. It's going to make a lot more sense once we start doing it. But it says if f of x equals g of x times h of x, so these are two different functions that are being multiplied by each other, then the derivative of f is the derivative of g, that's the first one, times h, no derivative there, plus g, the first one, times the derivative of h, the second one. And so if you look, I put it in words here too, the derivative of the first times the second plus the first times the derivative of the second. Here we go. First example, f of x equals x to the 15th times e to the x. These are two different functions. The words say the derivative of the first. So I'm going to take the derivative of x to the 15th. So this is my first, okay? So I'm going to call this first. And this guy second. Here we go, derivative of the first. That's 15x to the 14th power times the second, e to the x, plus the first, x to the 15th, times the derivative of the second, but the derivative of e to the x is e to the x. Done. Next one, square root of x times sine x. Okay, first thing I'm going to do with the square root of x, I'm going to rewrite it as x to the 1/2 times sine x. The derivative of the first, that's the derivative of x to the 1/2. Drop the 1/2 down in front. Multiply it by x. Subtract 1 from the exponent. That's the derivative of the first, times the second, sine x, plus the first, which was x to the 1/2, times the derivative of sine, which is cosine of x. All right. Oh, look at this guy here. Check this out. This whole thing right here is the first. And this whole thing right here is the second. Here we go again. Derivative of the first. The derivative of 8x to the 5th is 5 times 8 is 40, x to the 4th. The derivative of 9 is 0, so I don't have to worry about that. So there's the derivative of the first, times the second, which is 7e to the x, minus 2 to the x, plus the first function. So now I need some parentheses, 8x to the 5th, plus 9, times the derivative of the second. So the derivative of 7e to the x is going to be 7 times e to the x, because again, remember the derivative of e to the x is e to the x, minus the derivative of 2 to the x, which is still going to return 2 to the x, but it will also return the log of 2. And that one's done. You don't have to multiply them together or anything. Next one, I would encourage you to turn off the video. It looks like we're missing a symbol in here somewhere. I think this was supposed to be, oh my goodness, look at this. We got a mess going here, don't we? This was supposed to be 9 with a plus in front of it. Okay, hopefully that's in your notes there. Give that one a try. All right, so here's the first. There's the second. All right, the derivative of the first, that's 2/3 times 4, dropping the exponent down, times x. Reduce the exponent by 1, that's negative 1/3. The derivative of cosine is negative sine x. Now, those two are in parentheses to begin with, and because they're attached by subtraction, they need to be in parentheses after the fact. There's your first, times the second. So this is going to be the square root of x plus 9x to the 1/4 plus pi squared. All right, now we go plus, and then we need the first one back again. 4x to the 2/3 power plus cosine of x, and now I need the derivative of the second. And so in order to do that second one, I'm going to come up here and I'm going to change my square root of x to x to the 1/2. So let's continue. The derivative of x to the 1/2 is 1/2 times x. Subtract 1 from the exponent. That leaves me negative 1/2. Plus, I'm going to drop the 1/4 down in front of the 9. 1/4 times 9. Obviously, that's 9/4 times x. Subtract 1 from 1/4. That's negative 3/4. And then pi squared is just a number, so its derivative is 0. Look at that. That was fun, huh? All right. Let's take a look at some table values here. The table below shows values of two differentiable functions, f and g, as well as their derivatives. First one says, if h of x equals 3 times f of x times g of x, find h prime of 2. Okay, so the first thing I have to do here is find the derivative of h. So I'm going to start with that, h prime of x. And I'm going to use my quotient rule, or excuse me, my product rule here. So I'm going to use 3 times f of x as the first, and I'm going to use g of x as the second. So the derivative of the first, remember multiples in front, stay in front, so that's 3 times the derivative of f, which we're just going to call that f prime of x now, because I don't know what that is. So that's the derivative of the first, times the second, that's g of x. Plus the first, 3 times f of x, times the derivative of the second, so that's g prime of x. Once I have my derivative, we can go ahead and find h prime of 2. H prime of 2 means that I need 3 times f prime of 2 times g of 2 plus 3 times f of 2 times g prime of 2. So we need to go pick those numbers from the chart up top. We're going to go ahead and do that. The 3 is going to stay there. I need f prime of 2. That's negative 2 right up here in the chart. F prime, that's negative 2. G of 2, there's g. G of 2 is negative 1. Plus 3 times f of 2 is 4. And g prime of 2 is 2. And if you add all that stuff up, do a little bit of multiplication, all that, you should get 30. I would encourage you maybe to try and turn off the video, do the other one on your own. All right, the first thing I'm going to do here is find r prime of x. So I have two functions again, so I'm going to use this as the first function, this as my second function. Here we go. All right, the derivative of the first. Remember, f of x over 2 is just 1/2 times f of x. So the derivative is still going to be 1/2. Okay, that's the constant in front here. I shouldn't say constant, that's the multiple in front here. Times, I need the derivative of f, so that's f prime. The derivative of 2 is 0, so I don't need parentheses around this anymore. So that's the derivative of the first, times the second, 3 minus g of x, plus the first one. So I'm going to rewrite that one. I'm going to keep the 1/2 in front. Again, I like my fractions separate. F of x plus 2 times the derivative of the second. Now, the derivative of 3 is 0, but you have to be careful because there's a minus sign after that. And then I need the derivative of g, which is g prime of x. All right, let's plug in -5 and see what we get here. R prime of -5. Okay, so we have 1/2 times f prime of negative 5, that's 4, times 3 minus, well, you know what? Here, I should do this. I should actually write this out for you guys. F prime of negative 5 times 3 minus g of negative 5. I'll do this, yeah. So all I'm doing is plugging in negative 5. 1/2 times f of negative 5. Oops, no parentheses on there yet. Plus 2 times negative g prime of negative 5. How do you like all that? Okay, now let's plug it in and see what we get. All right, so now I have 1/2. F prime of negative 5 we said was 4, so I'll put 4 in there. That's being multiplied by 3 minus g of negative 5. G of negative 5 is negative 2. Plus 1/2 times f of negative 5. F of negative 5 is 3. Plus 2 times negative g prime of negative 5, which is positive 5. Holy cow, that's a mouthful, isn't it? And if you figure out what that is, you should come up with negative 15 halves. That is product rule. So along with product rule, we have something called quotient rule. Quotient rule looks a lot the same. A couple of differences here. The quotient rule says if f of x equals g of x divided by h of x, then the derivative of f is the derivative of g times h minus g times the derivative of h. So this looks very much like our product rule, only there's a minus in there. And then the denominator is simply h squared. Okay? So it's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. I'm going to look at it again as the derivative of the first times the second minus the first times the derivative of the second all over the second squared. So here we go. Here's my first. Here's my second. I need the derivative of the first, just like last time. Derivative of x cubed plus 1 is just 3x squared. Times the second, that's the bottom. So no derivative on that. X squared minus 5x. The only difference is we're going to subtract, and then we're going to have the top, the first, x cubed plus 1. Times the derivative of the second, that's going to be 2x minus 5, all over the second one, the denominator, x squared minus 5x, and we're going to square the bottom. And we're going to leave it for now. All we're doing is practicing how to find this. Next one. I would suggest maybe trying to turn off the video again. There are some tricky ones in here, but I think you can do it. Derivative of the first. The derivative of cosine is negative sine x, but the derivative of 1 is just 0, so I don't need to worry about the plus 1. Times the second, or the bottom, that's e to the x minus 5x. Minus the first, cosine of x plus 1. Times the derivative of the bottom, that's e to the x, because e to the x has its own derivative. The derivative of negative 5x is negative 5. Again, all over e to the x minus 5x squared. Well, let's keep going. If f of x equals tangent of x, then f of x equals sine x over cosine x. Remember, tangent is sine over cosine. We want to find f prime of x using the quotient rule. So here is a brand new derivative. A brand new derivative. We already know the derivatives of sine and cosine. we're going to do tangent f prime of x is equal to the derivative of the top. The derivative of sine is cosine of x times the denominator. That's another cosine of x. Minus the top, the first, sine x, times the derivative of the bottom. The derivative of cosine x is negative sine x, all over cosine of x. And if you remember from pre-calc, you can write cosine of x squared like this, but you would typically see it written like this, cosine squared x. That means cosine x times cosine x. Okay, if you need to, make yourself a little note out here. Cosine squared x equals cosine x times cosine of x, which is the same thing as saying cosine of x squared. Okay, all three of those mean the same thing. Now, we can actually clean this one up a little bit. So we're going to do that. F prime of x is equal to, in the numerator, look at what you got. You have cosine times cosine. That's cosine squared x. And then we have negative sign, so that's plus sine squared x. Hopefully something's going off in your head right now. All over cosine squared x. And hopefully it wasn't that you can cancel the cosines, because you can't do that. Go back to trig for a little bit. Cosine squared x plus sine squared x is equal to 1 over cosine squared x. And 1 over cosine squared x is secant squared x. So the derivative of tangent, okay, this is a big one. You're going to want to know this. Let's see. I'm going to write it like this. I'm going to say d dx, the derivative with respect to x of tangent of x is equal to secant squared x. Might want to highlight that one. You're going to need that one. Okay. All right, number 10. Boy, we got a mess in this one. We got some square roots in here. All right, since I'm kind of short on space, I'm going to rewrite this square root as x to the 1/2 power. And I'm just going to knock that guy off of there. All right, let's do this. The derivative of the first, the numerator. All right, the derivative of x to the 1/2 is 1/2 times x. Subtract 1 from the exponent, that's negative 1/2. Plus the derivative of e to the x, which is e to the x. There's the derivative of the first. Times the second, the bottom. X to the negative 2 plus x to the negative 3/2 plus pi minus the first. That's x to the 1/2 plus e to the x times the derivative of the bottom. All right, I got to be careful here. We got a negative exponent, so that's going to be negative 2x to the negative 3rd plus, actually, I'm going to be bringing down a negative exponent there, aren't I? I'm going to bring down a negative 3/2, so I'm going to do negative 3/2 times x. Subtract 1 from the exponent, that's negative 5/2. And the derivative of pi is 0. So I don't put it in there. All over the bottom, x to the negative 2 plus x to the negative 3/2 plus pi squared. Boy, is that a mouthful or what? All right, and then we're going to do some functions with tables as well here. So we're going to take a look at h of x. We're given a table full of values here, and we want to do h of x equals f of x over 3 times g of x. So this is a quotient rule problem. First thing we want to do is actually write out the derivative. So h prime of x, and again we're going to use that quotient rule. The derivative of the top, that's f prime of x, times the bottom, so that's 3g of x, minus the top, f of x, times the derivative of the bottom, which is 3 times g prime of x, all over the bottom 3g of x squared. All right. Now, I'm a little short on space here, so I'm going to do this. I'm going to just plug in 5 as we go. H prime, wait, what do we want? Oh no, I'm sorry, we want 2. All right, so I need f prime. So imagine 2 here, and here, and here, and here, and here. Okay, so here we go. F prime of 2. F prime of 2 is negative 2 times 3 times g of 2. G, this is x over here. This is g of 2 right here. That's negative 1. Minus f of 2, which is 4, times 3, times g prime of 2, that's 2, all over 3 times g of 2 again, so g of 2 was negative 1, and we're going to square that. And you just have to be careful trying to do this. It turns out to be negative 2. I would encourage you once again to turn off the video. Try the other one on your own. R prime of x is equal to, now this time I've got this little negative out front, so I can't forget about that. So that negative's got to stay. In fact, if it's me, I like just bringing the negative right up to the top right there. So I'm going to just call that negative g of x, and I'm just going to leave it up top. So I need the derivative of the top, so that's going to be negative g prime of x times the bottom, which is 1 minus f of x, minus the top. Now when I go to minus the top, remember it's negative g of x times the derivative of the bottom. Now again, look at the bottom. The derivative of 1 is 0. I have negative f prime of x. Got to be careful with all those negatives. And the bottom part's the easy part, 1 minus f of x. And we're going to square that whole part. All right, so I'm going to do the same thing that I did before. I'm going to plug in 2 here, 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 and here. Okay, so here we go. R prime of 2. Okay, I need negative, and then I need g prime of 2. So g prime of 2 is 2 times 1 minus f of 2. F of 2 is 4. Plus, because I'm going to make both of those negatives positive, g of 2, which was negative 1. And let's see here, this is, since I'm going to be multiplying, that's negative 1 times, and then I've got the negative inside with f prime, so I need f prime. That's also negative. My goodness, look at this. There's my numerator, all over 1 minus f of 2 again is 4, and we're going to square that. If you do the math correctly, we should come up with 4/9. And that is product and chain rule.